Today we're doing reduction of order. So you're going to start off with the general form, a at x, y double prime, plus x, b at x times y prime, plus b at x, y equals 0, always 0. The key thing to note here is you have two b at x's, so you have the same thing in front of the y prime and the y, except the y prime is multiplied by x as well. So what you're going to do, this type of equation has the property that the homogeneous solution, one solution is always x. Always, no matter what these other things are. If you have this form, your first solution is always x. So we're going to find the second solution, which we assume is some parameter v multiplied by x. And your two derivatives look like that, which you will then plug back into the original equation. And once you do that, it will reduce itself out to something like this. You'll get something times v double prime plus something else times v prime equals 0. Then you're going to sub in w equals v prime and w prime equals v double prime. So that gives you this, which is that same something from up here, times w prime plus something else times w equals 0. And that is a first order equation, very easy to solve. I'm sure you can do that. So you're going to solve for w, and then you have to, of course we want v, so you back sub. Same thing as up here, w equals v prime, w prime equals v double prime, and then you solve it again for v. And I know that's a lot of steps. Let's do an example for some edification. So here's our example here, 1 minus x squared times y double prime minus 2x times y prime plus 2y equals 0. So remember, our first solution is always x. It's just a property of this function. Y2 we've assumed is v times x, and we've taken our two derivatives there. And all we've done is sub it back into this equation here. So here is your y double prime, here y prime, and here is your y. Now we just reduce that out. It gives you here x times 1 minus x squared times v double prime plus 2 minus 4x squared times v prime. You can see the y cancel out there. So now we're going to sub in our w, and that reduces these values here, so we have a first order system. And of course we want to get rid of the first thing here, so we just divided it out to give us this ugly coefficient. And to solve that, our solution here, it looks like this: w equals c e to the negative integral of p at x dx, p at x being this thing right here. So we're just going to find that integral, which I'll let you follow along. It's fairly basic. But right there, that's what you get. 1 over x squared times 1 minus x squared. So what that tells us is w equals that garbage, which is the same thing as v prime. So remember, we want to find what v is, not v prime, so we have to integrate that again, which involves partial fractions. I won't go through it, but it's there if you don't remember how. So it reduces it into this nice thing, which is fairly easy to integrate. Gives you this to this here, just using log rules. Remember, you can divide when the negative is there. So the 1 minus x goes under the 1 plus x, and then the half goes in after that to produce the square root there. And now our solution here, y2, remember, is x times v. So it's just this times x, gives you that. And our final solution here, y equals c1x, that's our first solution, remember, plus c2 times our second solution. That's it, you're done. Math isn't so hard when you have the right tutor. Be sure to check out the description for links to other courses and topics. Also remember to tell your friends about the TheKFully channel.